we have a bridge circuit supplied from an ideal voltage source. Three arms of these bridge are resistors. This is a voltmeter of infinitely large resistance, and one arm of this bridge is a nonlinear element. This element is given by its volt-ampere characteristic as presented here. So our problem is problem of analysis of nonlinear circuit with one nonlinear element. This problem can be solved graphically. We replace the linear part, a part as seen from nonlinear element terminals, by Thevenin equivalent, and then perform graphical analysis. So at the left we have calculations, circuits necessary to calculate open circuit voltage and resistance, total resistance, as seen from the terminals of this nonlinear element. This is very trivial calculations. These are very trivial calculations. This voltage is simply voltage of our source, and this resistance is just resistance of this resistor. Then we have the following circuit to be solved graphically. A linear resistor, linear element, voltage source in series with a nonlinear element. Its characteristic is drawn here. Now we have to draw the so-called load line, a line which is designated by this resistance and this voltage source. Then this line presented here crosses voltage axis at 8 volt voltage and the current axis at 533, which is 8 divided by 1.5 K. These are milliamps on the vertical axis. Then graphically we may read the coordinates of this Q point, which is 2 milliamp and 5 volts, and our task is to calculate the power which is dissipated on this nonlinear element. It is product of this current and this voltage, which is 10 milliwatt. Now same circuit, but the different task. Now our task is to determine the value of this resistor R sub 3, so that the bridge operates at the balance point of balance, which means that this voltage across this voltmeter, reading of this voltmeter is 0. So to solve this problem we don't need a graphical analysis. It is a very simple problem. At the point of balance, this voltage between this terminal and this terminal is 0, which means that actually voltage across nonlinear element is exactly the same as voltage across this R sub 2 resistor, and this voltage can be calculated from a voltage divider, which is 6.5 as well. Then from element characteristic we may read that for 6.5 volt, which is here, Q point, and current 4 milliamp. So we know current that flows through this nonlinear resistor. Obviously it is the same current as flows through a resistor that we are looking for, that we are trying to identify. Then voltage across this resistor is the same as voltage across R sub 1, as the bridge operates at the point of balance. This voltage is equal 0. Then knowing this voltage, which is 1.5, and knowing this current, which is 4, already calculated, we may find from Ohm's law that value of this resistance necessary for this bridge to operate at the point of balance is 375